Hello everyone. Thank you for giving so much of love and respect to all my previous videos. I got a very good response for my last video, which was on Emotet, which is the kingpin of all malwares, because it is in the market for almost like 11 years now. So today I have come up with a new malware analysis, which is your PE32 Ransomware, which is currently being seen newly in the market, but has done a bit of destruction in the organizations. But the funny part was about this ransomware was when we started doing the forensic analysis for this PE32 ransomware, the strains that we identified, it was loosely binded connection and the key was being, stored inside the machine itself, which helped us to reverse engineer the ransomware and decrypt and decode all the files and everything. So I thought of bringing this uh, to 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 the audience and to the external people who are interested in malware analysis. Uh, Unlike Medusa, unlike Agent Tesla, unlike other WannaCry or something, this ransomware has everything which is created very intelligently, but because of the immaturity of the ransomware gang who has created it, uh, they leak the keys and they store the keys inside the machine itself, and it helped the decryptors and the forensic analysts and even us to reverse engineer the ransomware in an easy workflow. Now I will upload the complete analysis, the documentation, everything again on my GitHub link, and I will paste the link on my LinkedIn and my YouTube channel as well. So do follow the YouTube channel because I'll be uploading a lot of interesting stuff in coming days, not only from Malware's perspective, but my experience in bypassing web applications, mobile applications, those as well, Kubernetes, cloud native security, bypassing cloud natives, red teaming on clouds, threat hunting, forensics in cloud, and a lot of interesting stuff. As you all know, my most of my experience has always been in offensive, uh, but but side by side, I was very interested in forensics, and I used to do forensics from my college time itself. So that is why I have a good knowledge in threat hunting and SIM, your log analysis, and all that sort of stuff. So let's discuss about the PE32 ransomware. In simple terms, PE32 ransomware is similar like other ransomwares, which encrypts the files, but is a new, messy, and an immature level ransomware. Why I called it immature, I will tell in just in few minutes. But bear in mind that any ransomware in the world does a lot of destruction. But why I called it immature, I will discuss that in coming few minutes. But is an immature level ransomware that connects over Telegram channel. Now, why it is interesting? Because this is the first. It is not first time, but like first of its kind that connects through the bot of the channel in the Telegram that connects via the Telegram API and start the communications over there. Now, if we extend it, we have when we used to do the red teaming over it in previous ways, we used to exfiltrate data using various tools. Similar kind of scenario here, the attacker has built that he was actually trying to communicate over the API channel or API Telegram API of Telegram, okay, using the bot that is embedded and enabled inside the Telegram channel. Okay, now this technique is not new, but rare of its kind. Usually, we never get to see such techniques every day in life. That is why this ransomware is interesting, but uh, loosely and immaturely binded and locks and compiled in its in form into a malware. So over a Telegram channel using a bot as a back connection and communication encrypts your files and asks for money. to unlock them. It is sloppy, noisy, and very easy to detect, but it still works and can cause real damage. It talks, communicates to the attacker using the Telegram instead of secret servers or hidden networks. How PE32 ransomware works, the execution flow is the same. You get a PE32 executable file. The malware asks or auto decide if it should encrypt. We will see that in the dynamic analysis, why I have written it that it auto decides, or actually it is asking when I was doing the dynamic analysis, it was actually asking for which drive to encrypt. Okay. Uh, Fast and loud encryption immediately starts encrypting the most valuable folders using the P32S. Usually I got to see on my computer that was P32 extension like this. Interestingly, it creates a P32 key folder inside the C drive or D drive or share drive or OneDrive or in all the drives basically. It stores the ransom note in readme.txt. It creates a unique ID of your computer, and it keeps these three files to track whether it has locked your computer or not. Now what it does after that, sends message to the Telegram group chat, which attacker controls, your computer ID and status updates, which is your ultra fast encryption completed. Mistake, the attacker left their bot token visible, make it easy for researchers to spy or break it. So this was I was actually talking about. Now I have seen this algorithm very long back. I have never even read this algorithm much about it, but when I was analyzing this malware, I found out the from the strings that the encryption they are using most likely I will not use 100% because I'm not able to decrypt uh, the complete certificates inside the ransomware, but I will say that most likely it uses the Chacha 20 algorithm. We will discuss about this algorithm, what this algorithm is. Communication only through Telegram bot, no hidden servers. Coding quality very messy, full of spelling mistakes, which I identified. That is why I wrote this. Detection very easy. It triggers the disk repairs and encrypt system files randomly. Stealth mode, I didn't find anything, but there were some evasion tricks, but not like the pro attackers. Now the libraries used kernel 32, of course it will be used ntdll, bcrypt and crypt32dll, both the files. It creates the .log files. If I say .log and PE32 files, then some nodes and broken files. Expose secrets, leaks the Telegram bot token inside the code. Now, if we look for the Chacha algorithm, so what Chacha algorithm, it has a string called as expand 32 byte k, which is strongly associated with Chacha encryption algorithm. We will see that in strings, and we will see that especially in its expansion process and all those. I will come back to this algorithm in few minutes, but let's start with the analysis. So let me just go to full screen. Oops. Okay, let me clear this. Let me exit. So I have already downloaded the P32 Ransomware exe, and I've also created a pcap file for this. So let's start with the very primary thing, which is strings. P32 ransomware.exe, and let's run that. Let's see if we get something. So we get all our Windows files, the strict strings, targeted strings, some data strings, something like that. Here is the public certificate. So what I did, after doing all the analysis on this, I have created the string analysis. For this, I forgot. So it uses a PE32 log file, meaning a log file rule in execution. This is created to mark that encryption has already started or completed, preventing double encryption or signaling process. If you want, I can showcase that as well. Let me sudo sublime the P32, oops, sorry, strings.txt. You see it is running a rich program. .txt, .rdata, .pdata, .data, .relog, which is the P32 format. The very first, we will look for the PE32 log file, which is nothing but this is to created. This is a log file, which is nothing to check whether the encryption has actually started or completed, and it will also use to signal the attacker that whether the encryption has been completed or not. Then we have certain delimiter. These, when I was analyzing the whole strings and I was actually creating the graph for this, these are nothing but the delimiters to bifurcate the code from above to the next signaling. This is the expand 32 byte K which I was talking about, and when I was looking for this, I immediately remember I saw it somewhere, and it used to use with the salsa, but salsa got the converted to Chacha 20, so that is why I most likely suspect that it uses the Chacha 20 algorithm. Now this is reversed key. Now if you will reverse this key, this will become like this. Oops, sorry. So it is nothing but the bytes randomly generated purpose. So if you bifurcate it, this is D is nothing. It will replace or something with the T. So these bytes, something like that, are randomly generated purpose. Okay. So when I reverse that, I did it. No worries. Let me just make sure it is working fine. Sorry for that. Let's go to the next. Now this is general category cluster breakgram cluster script extension, which nothing but the Unicode metadata. Uh, let's look for something. Here is it is looking for the readme.txt. If I am correctly unable to find a user specified routes in the final search chain. So this is very critical. Readme.txt. This is the place where the ransom note will be placed. This is the log file. Log ultra fast completed means in this file, this file particularly is being used to communicate to the attacker that all the files have been encrypted. Drive size in GBs. Then we have time completed or not, total time taken, slow completed, staring ultra fast round, unknown encryption. What drive do you want to encrypt? When I was reading it, I was actually thinking, is it purposely placed, or it is actually an attacker asking for to actually encrypt something or not? So when I dynamically executed it, I actually got a pop-up, which drive you want to encrypt. But at the back end, when I was actually looking for the processes, it had actually started encrypting my files. Then this to me looks like some UUID, which is like I my hard guess this is for your drive volume or file system UUID, to uh, which could be the unique identifier for your target disk encryptions, which are being used in the organization. This is context.pe32. This is internal configuration context, which likely to stores the encryption parameter or victim specified identifiers. Bad, ultra fast, error messages if the encryption state. Uh, so why this is being written over here? Because it actually tells if the encryption state machine fails, and it will automatically tell the attacker over the channel in the telegram that the encryption failed. Then something, yep, this is our string, sorry, the telegram API. This is the user ID names, and this is the ransom nodes. Okay, this is the complete ransom node. Your files, greetings, your files have been encrypted and your sensitive data has been exfiltrated. To unlock your files and prevent public disclosure of data, payment is required. Please note that the cost of for file decryption and avoiding data separate. To establish trust and provide assurance, we offer the following. Then this, then it is asking for money, then you know bitcoins, depending upon displaying contact and all that sort of crap. Then this is the another IOC where we have to uh, where we can communicate. This is the telegram link. This is the user ID of the attacker. Then somewhere I did identify, yes, this is the public key of with which the encryption have done. This is the RSA basically public. Then anything interesting? Matches. Encodes. State series. Uh, anti-create key event. Fail to open device. Local IP. Calling the ntdll.dll. Invalid length. We carry P32 key, no key on AES chain, no context. Log P32 skip if there are no iterations, mismatch, encryption context, round data with 5 elements. I tried to decode this, but this is nothing but some bunch of crap. Then yes, this is something of important. This is this is your keychains basically. PKCS1 cryptographic error, PKCS1 ASN error 1, cryptographic key data malform, algorithm malform key error, description is depreciated, use display. Okay, so these are bunch of cryptographic errors that we get. This means that it shows the error handling for cryptography, especially with public key formats and base for data. Now it is starting all, start function pattern, building NFA, cannot build lazy DFAs for regex Unicode. Of course, with the for the cryptographic algorithms, when we use to encrypt the data using public key, we get these types of errors. Much I found here. These are your cryptographic algorithm errors. Again, file name contained, thread, set thread description has overflowed its stack. Nothing much. Yep, here is something again interesting for the local static guard, v-based destructor, vector constructor iterator, and all those functions. Let me check if and these are your function calls, which we always get when we are executing the P. We are always getting the your portable executable files. I did found the memory allocations of somewhere. Yes. Anti-create keyed event, keep alloc, anti-released event, anti-wait for keyed event, Windows call. Another was for memory allocation. I also found in this here. Then we have create thread, set file pointer, extended, find next file to write, kernel 32, show window, user 32.dll. This part I was very amazed when I saw that. Bcrypt generate a random values are being generated, IOCTL socket, and the socket connect, get socket, cert open store, decrypt message, anti-read, encrypt message, very important to encrypt the messages. And last is your bind, send, your crypt32dll, secure 32dll, ws32dll, bcrypt, adb API 32dll, and here is your get current process ID, get system ID, initialize, and this. So when I was analyzing this, what I did after that, I simply ran my Capa. So Capa gave a very important information when I was analyzing these functions. So let Capa run. So it's gonna take just few minutes. Okay. Yep. So it has provided as expected. The hashes basically, it's a Windows program. Architecture was AMD64. Defense evasion, as I said, I did find some of the deobfuscated and decoded files, obfuscated files, discovery, and these are nothing but your MITRE TTP. So NT behavior analysis, debugger detection. We have a timing delay check, query performance counter. We will come to this. We have detected that. Receive data, send data. We have checked that in the strings function. Resolve function is there. Create UDP socket. These all we just have seen in the strings function in the strings when we were analyzing it. This we have seen that we did see that some of the random values were being generated, encode data, and code discovery, memory permissions it was asking for. This all we have just saw that in strings. So Kappa comes very useful when we are mapping all these strings that are there, which we have just seen that. So what I do is I go to the strings and then I look to Kappa and then I go back to the strings, whether all the things that we have discussed is actually making sense. So this is what we were actually discussing. It is using the Salsa 20 or Cha-Cha 20. We did find that it was using the AES. We did find the certificate matching to that. We have query counter for performance under this file. We have communication, DNS, A64, and all that sort of stuff. So when I said that this ransomware is intelligently written, but it is still immature, that was what I meant. So that exactly what I was actually trying to tell at that particular time. Now let's run the floss just to double sure on the strings part that whether what we were actually trying to get in the strings, whether we have got it correctly or not. So Floss has also done a good job. We will start from here itself. These are our stack strings and these are our tight strings basically, and these are the decoded strings. So nothing new that we identified over there. So let me just strings UTF-16. These are your memory management and your Windows strings basically, if I'll say. Permission, denied connection, refuse connections, and all that sort of stuff is there. Your key, good. So, so nothing. I don't think that there's something that we will identify which we have. Okay. So leave it here. So far, so good. So let's start with the quick one scope that we generally start with. I have updated the quick one scope with the certain code at the back end. Now, the best part about this static analysis, malware analysis for static analysis for malware, this particular tool, the quick one scope, that you can modify a lot of code at the back end. This is so good written. I really want to give the author of this particular tool is really hats off. It is so good written and it is so easy that we just have to write the code at the back end for the analysis and it is so compatible with the code that you don't get much error codes in the code. It is so well written. The developer of this tool is hats off to that particular developer. And this is again is tremendous. So we'll start with our analysis from the VT file. VT file is to check at virus total whether this was actually being scanned and somewhere. Now we already know that this is a ransomware and it is already detected. Ransomware 19, somebody have just scanned it. This is the primary IP connecting over these two IP addresses and proof point emerging threats open detect has the rule source with it. Almost all antivirus detected it. Let's look what is the packer for this particular file. So we did find the signature be rich and this is the exact for the visual Microsoft Visual. So let's look if we are able to find certain domains. This is the Bitcoin address basically, not a particular domain. So we did find the wallet address of the attacker. Let's check the signature. We didn't find any corrupted signature or anything for Windows executable. Uh, let me do a quick help. We let's look at MITRE if something is okay. We did find the evasion is time-based evasion. We will look to this, why it is calling the time-based evasion. Credential access, network sniffing is there. Uh, let's look for if we get anything on resources. I highly doubt it's resource. We, as expected, we didn't find any valuable patterns. So let's analyze this. Okay, so it has completed the analysis. So if we say all import and export functions and strings that it has identified 358, categorized import 314, one registry, file 46, networking web 88, very interesting, networking and processes 39, expected, memory management expected, DLL expected. Of course, this is something interesting, evasion bypassing techniques, system and persistence, cryptography, information gathering 41. So if we go to above, um, if we start from here, so we have the function and strings, that NT create key, which is for the registry basically, to create a key in the registry. We will see that in the dynamic analysis as well, that it is touching the registry and it is creating a persistence over there. And we have certain file creating strings where we have create file write, get file information, get full path name, and what usually the ransomware or malware does, set file pointer extended, file next file write, get file type, and done. And this is your networking is to create the C2 communications. So what I did, I have created a complete analysis note for each and everything for everyone to easily understand that. So let me bring the notes here. So basic information, this is a Windows file, P32 Windows 32 executable. P32 is nothing but a standard executable file format for 32-bit Windows applications. Target OS specified intended operating system environment. The file is designed exclusively for Windows platform. So import and export analysis, the ransomware heavily utilizes Windows API functions categorized into domains like file operations, networking, memory management, process control, etc. This is the registry manipulation. We will see this in our dynamic analysis as well, where it is creating a registry key for the persistence for malware to persist inside the registry key. Then it is doing the file operations, where it is doing the file creation, read file, write file, flush file buffers, find first file extended write, set file pointer extended. Okay, this allows the ransomware to access and modify a file. This is essential for encrypting victim data. The heavy use of create file write and write file suggest means mass file handling typical for ransomware encryption operations. Networking and communication functions, socket, connect, send, receive, WSS startup, WSA cleanup. We can see that here as well. Here is your networking strings. Okay, let me just grab the file. What is the purpose? Is to establish the TCP/IP communication possibility to communicate with C2 server, exfiltrate information, and receiving the encryption keys. Uh, in the technical notes, I have provided get address information, bind imply capabilities for both and client server communication tools. Then we have process control, where it is creating a thread, exiting a process, terminate a process, which is nothing but the multi-threading and process control mechanism in every malware that it uses. Then we have the memory management, keep alloc, keep free, keep realloc, which is nothing but I am a bit shocked that the attacker was actually allocating the memory, freeing the memory, and then reallocating the memory. But it could have been done dynamically in uh, like the modern ways that we are seeing. But it is using the old C method. When we used to write code in C, we used to dynamically, C++, then we dynamically used to allocate memory in this way, but it's fine. This is nothing but dynamic memory management, critical for encrypting files of varying sizes efficiently. DLL and resource handling, load library, library, get module handle, which is nothing but to dynamically import the DLLs, potentially for obfuscation or modular lending of payload components. We did identify anti-debugging and evasion, is debugger present, query performance counter, sleep, which I was. So these two functions are actually responsible for the defense mechanism, which I have seen after a very long time, that it is using a performance counter along with the sleep function, and then set unhandled exception filter. This is to detect if it is running inside any sandbox or not, and then to modify or halt execution if analysis is going on. Like as I said, query performance counter is often used to detect sleep skipping techniques in sandboxes. Cryptographic functions, gen random, which is a function to generate random values, and code pointer is so is crucial for generating secure random keys, and encode is to protect sensitive pointers from memory corruption attacks. Information gathering function, get system info, get command line, and get startup info right. Gather system and environment info, tailor attack based on the system configurations. What are the linked DLLs to it? Kernel 32, core system, user 32, GI interaction, PIP32 DLL, which is for the old cryptographic algorithms. Let me write it completely for everyone. Old cryptography algorithms to import, such as for the certificates, such as for certs, etc. WS232 DLL is for networking, and bcrypt usually is for your newly crypto. Okay. And we all know the secure 32 DLL and NTDLL like this. Yep. Then we identify the PDB inside it. We didn't find that in strings, but when I was analyzing when I did modify the code in Quickscope, I was able to find the PDB program database, which didn't give me much information, but it actually indicates that the binary was compiled without removing debug symbols. I was trying to find the internal path or something, but I didn't find anything. Hard-coded registry keys I didn't find, embedded PE files I didn't find, and any unusual artifacts I didn't find. But I did find some of these stack strings, which is, we have already discussed that. When I reversed it, it becomes something else. We did find the tight strings, and these tight repetitive patterns suggested encrypted configurations or unique IDs. When we decoded this, because this is hex value, so it becomes RHNL, AI4W, something, then E3, and I don't know. Decoded strings appear partially random and maybe encryption keys. Deep node could be an abbreviation or code word used internally. If systematically reverse or substitute might lead to real instructions or keys. And these, actually, I was writing the Yara rule for this. I did write the Yara rules. I think I did at the end. Yep. Here is the Yara rule for this. I was actually making the Yara rule. So here is the Yara rule for this. This is the ransom node I tried to create. Telegram token, P32 log, make a 2, this, then this, then we have magic algorithm, ransom contact, drive prompt, this, then we have the condition where the if it matches this, which is nothing but the PE header for the MZ. MZ is the PE header, basically to identify this is a portable executable, file size is less than 10 MB, 5 over ransom node, Telegram token, and then with this condition, and then we get this. Then I did create a Telegram bot detection in SIM. Index, your index name, source type sysmon, event code equal to 3, where destination host name like percentage telegram.org, or if the destination IP matches this, table time, source IP, and image, and correlated rule which I created with this, where file name, the event code is equal to 11, and the file name is p32c, and or if the file name is p32 stats count by file name, target file name, host name, where count is greater than file, and it will be able to detect it. So this is the detection. These are the hashes. I did calculate the entropy. The entropy for this, for the text, is too much when I was analyzing it. So how you can analyze it? You can use any tool. I particularly use PE for this. Let me just grab my Windows. I don't know. Nowadays, Windows have gone crazy basically. Okay, let me just grab the Windows. Power on again. It's gonna take only 2 minutes. Okay, let me just shut down the uh my this thing, because I have already added all the required data to the EDR, sorry, the Windows ATP basically, the EDR for Microsoft. Okay, just turn it off. Okay, fine. Uh, let me bring down the image. Let me bring the die. Detected easy, sorry, PBR I said. Detected easy basically. Let's bring the ransomware. Let's click on anything. Let's go to entropy. Now if you click on the text entropy, you can clearly see the pattern over here. It's too much distorted. It means there is something which is definitely embedded. All your malware encryption and everything is embedded over here. Okay, even though the entropy for this is also a bit high, but for text, if I clear it out, it is very much visible that something is going on here. So let me close this. Let's go to our actual scenario. Let me open the Wireshark. Let me make sure that my settings are fine. Show fine. Here, here is the color 0. Let's put a filter at DNS and then quickly close the Java box. So we get a lot of DNS requests here. Don't worry, we'll put a filter on the inline malware. Let me fire up first of all the Process Explorer. Okay, we'll get this. Let me close the complete this. Let me do some cleanup first. We are ready. Let me just open the process monitor as well. So we can put a filter on filter process name. Process name is PE32 Ransomware. Let's see. Okay, let's go ahead and fire the malware. Oops. Double click it. Now, this particular thing I was actually talking about, that it is actually asking for at the back end that, whether you want to execute it complete by yourself or what do you want. But if you see at the back end, this is something it is already doing a lot of stuff. Let it run for some time and then we'll come to see that what exactly is happening at the back end. Let's start directly from here. Okay, let me check if it has already created the file. Okay, it has already started creating the file. Okay, let me just close this. This is already closed. I don't need it anymore. Let's look at the Telegram. It has tried to connect to the Telegram. Okay. Let me put some filter onto this. Filter. Selected. I think it didn't capture anything. I think it has not yet communicated over here. Let me run it again. Let's start the process capturing again. But if you see, it has already created. Let's go and check if it has created the files. See here, if you see, it has already got the context file, the ID of the machine. This will be the unique machine ID, if you see that. And if you see if what is there in this, so this is the encrypted code which is there. Now this is the machine ID. If all my machine is encrypted, I have to communicate with the attacker uh, about this. But let's see what happens at the back end. So process start, thread created, image loaded. It first call the NTDLL. It create in the prefetch. It has already created a prefetch file over here, and it is actually it is actually touching the registry. But if you see the desired access is read, query value, registry key. Here is the persistence where it is trying to persist, and then it is creating a file over there, and then con host process. It is actually querying the con host process, and here we have extracted it. Now it is talking to the Windows DLL. All the DLLs that we have seen in the strings are being loaded. Secure 32 DLL as well. Smart locker. Now it has touched the bcrypt to encrypt everything, to start encrypting. Disable. It is checking for what accesses that we have in this. Now if you see, it has actually created a file in C. It has actually created a folder directory, and after it has created a file. It has written a file, and it is now reading the file. Is now moving back to the C drive, checking the device, is again going to the C drive, creating it, thread exit, and after exiting, it's actually checking. But let's go back and check if it is querying to uh, the api.telegram.com, because when I executed it previously, the first call it made was to api.telegram.com. No worry, this is host only, so I'm not much worried. But let me restart it again. Let me check. Let me just continue without saving. Let me just run it again. It is running. It's only querying for this thing. I think because the token is saved inside the machine, that is why it is not querying the Telegram API. But actually it should does the second time as well, because I did clear all the tokens before executing it. So it has automatically identified it. Let me allow this on device just for testing purposes and see what we get at the back end. I'll just press 2. See, here it has now started contacting the Telegram over this IP. Now this is already blocked in this thing. All the hashes and everything is being stored, so I'm not much worried that this is my sandbox machine itself. But this is what I wanted to showcase in this ransomware, that this is a bit interesting ransomware of its own kind, because what we have seen in this ransomware is that it is actually communicating over the Telegram, and 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 detecting everything and tries to exfiltrate over the Telegram channel. So I hope you enjoyed and liked the video. Uh, I really, I'm getting a very good response for my book as well. But I really want everyone to go and buy my and purchase my book. Basically, it is going to give you a lot of insights about such digital forensics and digital forensics and incident response. This I have given my lifetime experiences in this book. I have added a lot of stuff in this book. I will paste the link again in the YouTube video. I hope you have enjoyed the video. Thank you so much. Have a nice day ahead.